Okay, good morning, students. Now we'll see the second topic, that is Newton-Raphson method. In Newton-Raphson method, how to solve algebraic and transcendental equations. Okay, Newton-Raphson method, we will call it as Newton's iterative method also. Let f of x equal to 0 be the given equation, and let x naught be an initial approximate root of the equation f of x equal to 0. Then, by Newton-Raphson method, next approximate root of the equation is given in the following formula: x1 is equal to x naught minus f of x naught divided by f dash of x naught. x2 is equal to x1 minus f of x1 divided by f dash of x1. x3 is equal to x2 minus f of x2 divided by f dash of x2. Means current root will depends on the previous approximate root. That's why it is called Newton's iterative formula. x4 equal to x3 minus f of x3 divided by f dash of x3. So in general, the Newton's iterative formula is given as given below. Xn plus 1 is equal to xn minus f of xn divided by f dash of xn. Find a real root of the equation x cube minus 2x minus 5 equal to 0, corrected to 3 decimal places by using Newton's Raphson method. Why you are going to study this Newton-Raphson method means it will converge faster than the regular policy method. That's why I took the same problem what you did in regular policy method. There you got a root for this equation in ninth stage, 8th stage. Here you will get faster than that one. Same guessing root, same procedure, but here you will require only one. Both are not required. Okay, f of x equal to 0, list f of x, and by trial and error method, guess where it is positive and where it is negative successively. You know already at 2 it is negative, at 3 it is positive, but that means root lies in between 2 and 3. But nearer to which one? Either 2 or 3. At 3 it is 16, at 2 it is minus 1. So near to 0 is minus 1. So root lies near to 2 only. And the root is nearer to 2. So we'll take it as x naught. Let x naught is equal to 2. Then by Newton-Raphson method, once you get the initial approximate root, you can proceed with the Newton-Raphson method. Then by Newton-Raphson method, next approximate root of the equation is given by the formula xn plus 1 is equal to xn minus f of xn divided by f dash of xn. Now we'll proceed the remaining in tabular form. For this, list what is x naught or x naught already there, f of x and f dash of x, and the formula for xn plus 1. From f of x, f dash of x, it is very easy, polynomial only. So 3x square minus 2. Now we'll take the table. First one is xn column, f of xn column, f dash of xn. Why? Because means these three components are required for the formula. And then xn plus 1. First, we will start with x naught. X naught is equal to 2 and f of x naught is minus 1. Substitute here, and f dash of x naught is 10 by substituting here, and substitute these three values in this formula. You will get x1 is equal to x naught minus f of x naught divided by f dash of x naught, which is 2.1. Take this 2.1 as x1 here, and f of x1, f dash of x1, and x2, 2.0946. And take this as x2 here, and f of x2, find out f of x2 and f dash of x2, go for x3. See, x2 and x3 both are same, so we can stop the iteration process here. Hence, an approximate root of the given equation is x is equal to 2.0946. Okay, next problem. Estimate a real root of the equation x e power x minus 2 equal to 0, corrected to 4 decimal places by using Newton's iterative method. Same, list out f of x and then guess two values by trial and error method at 0, minus 2, at 1, 0 point positive. So root lies in between 0 and 1, but nearer to which one? Either 0 or 1. At 0, minus 2, at 1 it is 0 point. So root is nearer to 1. So take it as x naught as 1. Then by Newton-Raphson method, list out the formula and proceed in the tabular form, the remaining procedure. List out f of x and f dash of x, xn plus 1 formula. Take the table, first xn column, f of xn column, f dash of xn column, and xn plus 1 column. What we took x naught as 1 and f of x naught, f dash of x naught, x2, sorry, x1 by using this. And take these x1 here, find out f of x1, f dash of x1, and by using these three values, calculate x2 by using the formula. List out x2 here and find out f of x2, f dash of x2, and by using these three, calculate x3 value. Then take x3 here, f of x3, find out f dash of x3 and x4 using this formula. See, all these two values are equal. Hence, we can stop the iteration process and we can list out an approximate root of the equation as x equal to 0.8526. Next, predict a root of the equation x into tan x plus 1 equal to 0, which is nearer to x equal to pi by using the Newton-Raphson method. Here in the question itself, it is mentioned where you have to find out. So no need to go for trial and error and guessing. Directly you can take x naught as pi. And you take f of x as x into tan x plus 1 equal to 0. Same we can write it as x into sin x plus cos x equal to 0. Why I am writing like this means x into tan x differentiation will become secant square x. You will get a little bit confusion how to operate secant square in the calculator. No, you can calculate secant square can be written as 1 by cos square. If you don't want that much confusion means convert sin, tan to sin and cos, or cot also given means cos and sin. So f of x is either x into tan x plus 1 or f of x is x into sin x plus cos x. See, you have to use same pair. If you are going to use f of x as x into tan x plus 1, same f dash of x you have to use. If you are going to use f of x as x into sin x plus cos x, corresponding f dash of x only you have to use. X naught is equal to pi. Then by Newton-Raphson method formula, f of x corresponding f dash of x, both I am showing here. Whichever you are convenient, you can use. I think f dash of x equal to x into cos x is only convenient. So use f of x as x into sin x plus cos x. The process of finding the root is shown in the following table. F of x, x into sin x plus cos x, and f dash of x, x into cos x and xn plus 1 formula. Don't forget that the function has trigonometric values. When you are operating with the numbers, keep your calculator in radians mode. Xn column, f of xn column, f dash of xn column, xn plus 1 column, x naught as pi, or you can take 3.1416, or in your calculator pi is available directly, you can take pi only. And f of x naught, f dash of x naught, and x1. Take this x1 here, f of x1, f dash of x1. By using these three, calculate x2 value. Then list out x2 here and find out f of x2, f dash of x2, calculate x3 by using these three values. Then list out x3 here, f of x3, f dash of x3, and x4. If you observe x3 and x4, 2.7984, 2.7984. Hence, an approximate root of the given equation is x is equal to 2.7984. Next, we will see one more problem. Apply Newton's iterative method to find a root of the equation x into log x base 10 is equal to 1.2 corrected to 4 decimal places. List out f of x as x into log x base 10 minus 1.2 and guess the root which is nearer approximate root. With this we can say that root lies in between 2 and 3 but nearer to 3. So take x naught as 3. The formula for Newton-Raphson method, xn plus 1 is equal to xn minus f of xn divided by f dash of xn. Here, if you want to calculate f dash of x, here not log x base e. You know the differentiation of derivative of log x base e as 1 by x. Log x base 10, we don't have direct differentiation. So, by using logarithmic properties, create one more log with base e. F of x is equal to this one, and f dash of x is equal to d by dx of x into log x base 10 minus 1.2. So use the UV rule of differentiation. X differentiation is 1 log x base 10 plus x into d by dx of log x base 10. Log x base 10 can be written as log x base e into log e base 10. Log e base 10 is constant and this value 0.4349. You can use it 4343, 43429. So we can use d by dx of log x base is 1 by x. Hence, f dash of x is equal to xx will get cancelled 0.4343 plus log x base 10. That you can list out in the tabular form. F of x, f dash of x, and formula for xn plus 1. Then xn column, f of xn column, f dash of xn column, xn plus 1 column. X naught is 3, f of x naught, f dash of x naught, x1. List out x1 here, find out f of x1 and f dash of x1, and then calculate x2 by using the formula. Then take x2 here, f of x2, f dash of x2, and x3. Both are same. Hence, you can list out approximate root as x is equal to 2.7406. Like this, you can proceed the remaining problems in this method. Okay, thank you. We will see the next topic in next lecture video.